Assalamualaikum. Today I will present my PLC lab work, the soft drink beverage mixer system. The system simulates a real factory process for making a soft drink using automation and control system through a PLC. Okay. The goal of this lab is to build a smart system that can automatically fill, stir and heat the ingredient to make a soft drinks. It uses sensor, motors, valve and a heater, all controlled by a PLC. Okay. So, as I mentioned the component above earlier, I choose the component to build a complete automated system. The PLC is like the brain. It receives input from sensor and send output to control device like motors and heaters. Each component has a clear job. For example, the level sensor check water height, the temperature sensor monitor the heat, and the buzzer alerts when the job is done. Okay, the sequence of this system is first, when we press the start button, it will start the batch process system. The steer motor M2 and M3 will turn on. In this process, pump will energize and solenoid valve 1 in open position to allow reverse osmosis water to flow into the tank. Until you reach the level sensor 2 and 1, the pump and solenoid valve 1 will switch off. Okay, so when level sensor S1 scans the water level, analog output will turn on. The heater system until temperature sensor read the temperature reach to 100 Celsius. Okay. So when the temperature sensor reach to 100 Celsius, solenoid valve 2 will in open position until water level in the mixer tank reach 85%. Okay. So if the water level in the mixer tank is 2%, the steer motor M1 will turn on. After the water level in mixer tank reach 85%, solenoid valve 3 will in open position to allow a dissolved sugar flow into the mixer tank. Okay. Only 12% of dissolved sugar added the solenoid valve 3 will in closed position. Okay, next the flavor concentrate will be added for 3% by controlling the solenoid valve for open and closed position. Okay, after mixing all the ingredients for 10 minutes, the solenoid valve in open position and start draining the soft drink waters. When the water level drops to 0%, the solenoid valve 5 is in closed position. Okay, when the mixing cycle operation has repeated 12 times using this counter operation, 12 times, the operation and buzzer will sound with 2 Hz frequency, and the filling and draining operation will not restart even if PB1 is pressed until reset is pressed. If the water is in single tank below to the level sensor 2, and solenoid valve 2 in closed position, the sequence of the heating process will be continuous while the mixing operation will be on hold. Okay, so I'm using digital input like start button, stop button, level sensor 1, level sensor 2, and tag 2. Okay, and for digital output, I'm using motor 1, motor 2, solenoid valve, steer motor 3, valve 1 until 3, and buzzer. Okay, analog input and output, temperature sensor, and heater. Okay, these are the input and output address I use. Input like buttons and sensor give a signal to PLC, and the PLC process the logic and active output like motor, valve, and or the heater. Okay, uh, that's all from me. And from this lab, I learned how to design a real automated system. It helped me understand how sensor and output work together using PLC logic. These skills are important in industry like food processing, where automation is widely used. Thank you.